One, we're discussing the hypothesis test that will be on your test next week. All right, so the World Health Magazine claims that Michigan doctors recommend aspirin more than New York doctors. To test this claim, a random sample of 200 doctors is obtained. Of this, 100 Michigan doctors, so that's my N1, indicate, and 82 out of 100, so 82 is my X1 bar. Again, an N1 is my 100. And it says 75 out of 100, so that's my X2 bar. Out of 100, that's my N2. Of New York doctors recommend aspirin. Is this claim indicate that Michigan doctors recommend it more often? So that's my HA is going to be more often, which will be a greater than. So I'm going to have Michigan greater than New York. Okay, my parameter. First of all, I'm going to say P1 minus P2 is equal to the true proportion of doctors that recommend aspirin. And I'm doing Michigan minus New York. My HO is that P1 is equal to P2. My HA, P1, my Michigan doctors, is greater than P2. My assumptions and conditions, it says that I have both are from a random sample. And we have N1 is equal to 100, which is greater than 30. And N2 is also equal to 100, which is greater than 30. So my normal conditions met. The test is a two-proportion z-test. And we're going to find the test statistic. The way that we're going to find the test statistic is we're going to use our calculator, and we're going to go to Menu, Stats, Test, and we're going to go to a two-prop z-test. So let's jump to our calculator. And I'm going to go to Menu, Stats, Test, two-prop z-test. Okay, so successes for the first one, I have 82 out of 100 because that's how many Michigan doctors, and success 2 was the 75 out of 100 New York doctors, and we're going to have a greater than because we said the X1 was greater than X2, the New York was greater than Michigan. So here we have a p-value of 0.114 and a z of 1.2. So my test statistic is z equals 1.2. And my p-value, which we're going to put in a second, 114, I'm just going to put it there for us. So my draw labeled shade, I have a normal model, 0 and 1, 1.2, shaded here, and that's my p-value, 0.114. So I made sure I labeled all the different things I have labeled. I have the N labeled here, and I have the mean labeled, and I have my Z labeled. The p-value I already found above, and that's 0.114. But since the p-value is greater than alpha, which I think I put as 0.05, we're going to fail to reject HO. And we are going to say there is not convincing evidence for HA. And what is HA? For HA, which is Michigan doctors recommend aspirin more often. Okay, then New York, I guess. Okay, next one. We have a random sample of 32, so N1. And we have an average of 45.6, and that's going to be X bar 1. And I told you I needed to give S1, and that's 2.3. And 34 is my N2. 1.5 is my X bar 2. And S2 is going to be 4.1. And I'm looking at an alpha of 0.01. My parameter for this one, because their means is mu, so mu1 minus mu2 is equal to the true mean, number of spots on fish, And I did my, I'm going to call it my LX fish because it's actually a real fish. You can look them up. Minus the grouper fish, the panther grouper. We'll pull up PG, panther grouper. Okay, my ho is that there's no difference, so mu1 is equal to mu2. My ha is, this asks for different number of spots, so that would be a not equal to. So my ha is mu1 is not equal to mu2. My assumptions and conditions, I look and I say, yes, there is a random sample of both. And my large sample is I have n is equal to 34, and 2 is equal to 34, and that's bigger than 30, and 1 is equal to 32, and that's bigger than 30, so large sample is set. Oh, did I? I sure did. I messed this one up. I sure did. I have N1 and N2. This is not right. Coming back here, this is not correct. Sorry, I just realized that. Because this is PQ. This is NP, NQ. I realize this is proportion and I messed that up. So I would need to do NP1, N2, P2, N1, Q1, and N2, Q2, all bigger than 10. So I apologize. I did mess that up. Okay, so to do that, I would say, okay, each one of mine. So I can see I have how many do I have? I have 82 in one sample, right? And then 18 that do not recommend it, 75 in this sample that recommend it, and 25 that do not. But all of those are greater than 10. So that's what I should have done. And I realized on my video tomorrow I messed that up as well, but that's what you're going to have to do instead. Okay, so sorry, back to this one. I just realized what I had done. Okay, so this is going to be a 2-sample t-test for means. My test statistic, we're going to go ahead and put my data in and get a test statistic. So let's go ahead and do that. And to get that, it's going to be, well, I'll go ahead and put what you put. So you're going to go to menu, stat, test, and it's a 2-sample t-test. Okay, so menu, stat, test, 2-sample t-test. Okay, so I'm going to do statistics because I have stats. I don't have any data. So my stats, my X1 bar, I already circled. That was 45.6. My S1, which I gave you, 2.3. My N1 is 32. My X2 bar is 41.5. My S is 4.1, which I had to give you later, and then the N2 is 34. And it is a not equal to because that's what it asked for, and here we go. So T is 5.4, and p-value is really tiny, so basically 0, 1, so yeah, it's basically 0. So your test statistic T is 5.4. So this is how you're going to draw it, 0. T with your degrees of freedom, which it gives you on here. You got to make sure you put your degrees of freedom. It gives it to you here at 52.5. It gives it to you on your output. And then this was 5.4, and I have to put negative 5.4 because it is the ha, remember, not equal to. The p-value is basically 0, is super tiny. So we're going to be, since p-value is less than alpha, I'm going to reject ho, and I'm going to be, there is convincing evidence for ha. And what does ha say? That there's a different number of spots on the 2 species of fish in the study. Okay, and that's it. Okay, and the last one is a group of women participated in the study. Each woman owned their own smartphone and wanted to test if they could text words in a minute in a quiet room versus a noisy room. Is there convincing evidence that a woman texts the average more women in a quiet room? Use point 1 for this alpha. Okay, so for this one, tomorrow I show you how to put it in by hand without putting this in, but I'm just going to put the data in for you and show you this. list spreadsheets. And so this is going to be list 1. So this is a list 1, so this is going to be quiet. I'll just put quiet in here. And then this second one is going to be noisy. And then this one's going to be the noise difference. I'll put noise diff. Okay, so for quiet, I'm just going to put in 36, 30, and each, like number 1 is woman number 1, woman number 2, woman number 3. Like this is the difference that they had. 30, oh, I guess that should be, sorry, 36, 36, 37, 38, 40, 30, 34, 33, 35, 32, and 33. Okay, and the noisy women is 30, 31, 29, 33, 28, 27, 30, 30, 31, and 29. Okay. Then the noise diff, I'm going to go ahead and put in the equal sign there. I'm going to put A minus B, and it's going to do the math for me. All right. You could definitely, and you'll see on tomorrow's video, I did the math, and I just went in directly and did it like this. But for this, that's all I did for now. So we have this here. I've got my data in, so let's go ahead and start. So I've got my parameters going to be mu d, which is equal to the true mean of the differences of number of text messages in 1 minute in a quiet minus noisy room. Okay, where mu d is equal to 0, and this is mu d. It says, is it that we could do the quiet more? So we're saying quiet would be more, which would be greater than 0, since quiet would be more. So more minus less, obviously that's going to be bigger than 0. Random sample. Now, this was not a random sample. It's not stated. Random sample not stated. And so we're going to proceed with caution. So we're going to proceed, but we're going to say we have to be careful because we're not guaranteed that this is going to be, the results are going to be reliable. Secondly, my n is equal to 10, so we have to check the graph. So let's check the graph. So we're going to go to data statistic. We're going to go to noise diff. And we see it looks like we've got one guy that is an outlier. And in fact, if we do a plot and we look at a box plot, indeed it is an outlier. So we have to be careful on that one too. So we have one outlier. And the rest of everything else is symmetric, is approximately normal. But we're also going to be cautious here because of the outlier. This test is called a paired t-test. To find the test statistic, we're going to go to menu, stat, test, and we're going to go to a t-test, and we're going to go to data. And we're going to see a list, and we're going to use the drop-down menu. Okay, and so I go to calculator page, and I go menu, stat, test, t-test, and I'm going to go to data, and I'm using my drop-down menu. Oh, I forgot to tell you, mu is going to be 0. My list is going to be a drop-down menu, and I called that noise diff. And we said, is it convincing evidence of greater than? And we did okay. And we have a t of 5.9 and a p-value of really tiny, 0.001. So we're going to have t of 5.9 and a p-value of 0.001. So you have this, 0, 5.9, and 0.001. And oh yeah, on here, remember we had our ho with mu is equal to 0. Okay, and then so since p-value is less than alpha, we're going to reject HO, and we have, oops, the next one we have convincing evidence for Ha, and Ha is that the quiet room, more text messages than noisy. But we have to say we are cautious, as our results may, we're not sure, not be reliable because it was not a random sample. And we had an outlier in our data when it was n was less than 30. Okay, that's it. And I do want to point out I did make a mistake on tomorrow's video. When I did the assumptions and conditions, I had the n greater than 30, which again, it would be the groups of 75. I had the groups we had 82 doctors that said yes. We had 18 that said no, they don't recommend. On this New York, we had 75 that said yes, and we had 25 that said no. But all of those are greater than 10, and that's what the condition is right there. So I do want to make sure I point that out because tomorrow's video, I do know that there is a mistake. All right, thank you very much.